So these are kind of some fun trig derivatives that require a little bit of extra work. I often call these double chain rule problems. They're really interesting, or at least I think they're interesting. How they work is you have something like a sine or a cosine function, but it's raised to some power, like to the third power or the fourth power. And what I like to do is I kind of like to rewrite these in a way that makes a little more sense to me. So I'm going to write y equals, and it's sine cubed of 2x. That really means this. It really means I have sine of 2x. So there's that. And then sine of 2x, and the whole entire thing is cubed. So in my mind, totally a chain rule problem. There's an inside-outside going on here. There's a little inside, and then there's this bigger inside, something cubed. And so we're going to kind of have to tackle this thinking chain rule, but using inside-outside kind of a thing. So let's try this. We're going to find the derivative. So we're going to write dy dx, the derivative, equals, and we're going to go through the process here. So it's the derivative of the inside. So I'm going to start with deriving the very inside, right here, the 2x. I'm going to start with that first. So the derivative of the inside, derivative of 2x is 2, times the derivative of the outside. Well, right now I'm focusing on this as my outside. So the derivative of sine is cosine. So cosine, keeping the inside 2x. So now I've got the derivative of 2x is 2. The derivative of sine is cosine, keeping the inside 2x. That's kind of where I'm at right now. So now that I got that figured out, now I'm going to go bigger here. Now I'm going to do the derivative of the very outside. Now I have something here, something to the third power. So I'm going to power rule that. That's going to be 3 something to the second power. And that something stays the same. Sine of 2x stays inside of here. And then technically this is my answer. I know it's not very nice looking down below down here, but it is my answer. Now all I'm going to do is maybe rewrite it a little bit. So I'm going to write equals, and I've got 2 cosine times 3. So let's do 2 times 3 is 6 cosine of 2x. And then I have sine of 2x squared, so I'm going to rewrite it like this. Sine squared of 2x. Use different notation. And then this thing at the bottom down here is my final derivative answer. 6 cosine of 2x times sine squared of 2x. Double chain rule. So like I said, they are pretty fun problems, and we're going to see all different types. We're going to kind of work on these for a little bit. So let's try this one. If you want to pause the video and give it a shot yourself first, might not be a bad idea. So here's what I do. My very first step is I rewrite it as y equals, and I change it to 4 times cosine of x plus 2, and it's squared. So it's this whole entire thing squared. That's my setup. So I'm looking at it thinking chain rule, but I'm thinking double chain rule. I see a little inside, and then I see a really big inside that I'm going to be kind of working with. So let's start. Let's find the derivative. So dy dx equals, and we're going to do the derivative of the inside, so I'm going to do this very inside here. So the derivative of x plus 2 would just be 1, times the derivative of the outside. Well, now I'm talking about cosine. So the derivative of cosine is negative sine. So I'm going to have times negative sine. So I'm going to write sine. Let's put the negative sign over here. Times negative sine. And then the rule is keeping the inside, so keeping the x plus 2. Times the derivative of the outside. So now let's think outside here for a moment. I'm now looking at something squared. So power rule this thing, something squared. Well, it's 4 something squared. So if you really think about it, power ruling it is going to give us this. We're going to have 2 times 4 something to the first power. And then that something stays the same, cosine of x plus 2. And now I'm going to clean all this up and say, you know what, let's make this a little nicer. So my derivative equals, Negative 1 times sine. 2 times 4, well, 2 times 4 over here, that's easy, that's 8. So I'm going to say I have a negative 8 sine of x plus 2. And then I also have a cosine of x plus 2, the first power, so cosine of x plus 2. And then that is going to be my answer. The derivative dy dx equals negative 8 sine of x plus 2 times cosine of x plus 2. So yeah, these can be kind of complicated. They're just kind of messy. The more you try, the better you get. So if you want to try one more here, you can pause the video and see if you can get it right. I'm going to go through this one. I'm going to do what I've been doing on these other ones and kind of practice inside, outside. So this time what we got here is we have negative tangent of 3x squared. So it's not really a double chain rule. When I go to find f prime of x, I only have this one inside piece, 3x squared, to kind of deal with. So what I'm thinking is we'll just go through the regular chain rule and say derivative of the inside. So 3x squared derived would be 6x times the derivative of the outside. Well, on the outside I have a negative tangent. So what I'm thinking is if it's negative tangent, let's put the negative sign here in front of the 6. And then let's say tangent, the derivative of tangent is secant squared. And then the rule with chain rule is you do the derivative of the inside times the derivative of the outside, keeping the inside, keeping the 3x squared. And if you think about it, this is probably fine as an answer. I actually don't think I need to do anything else. I probably can circle all of this and feel like I'm pretty good to go here. So that's just a little chain rule with trig practice. We're going to have to do more in class, but I hope that helps a little bit.